Welcome to Tesla's Gigafactory, spanning over 5.3 million square feet. It's one of the largest buildings on Earth. This colossal facility, strategically located in Nevada, produces more lithium-ion batteries than any other plant in the world. Designed to support Tesla's mission of accelerating the transition to sustainable energy, this state-of-the-art factory doesn't just manufacture electric cars and batteries. It's redefining the future of clean energy. Today, we'll explore how this groundbreaking facility earned its nickname, the machine that builds the machines. The story of Tesla's Gigafactory begins with a massive, world-changing problem. By 2014, Tesla was riding a wave of growing interest in electric vehicles, EVs, driven largely by the success of its Model S sedan. But Elon Musk and his team knew that the real test lay ahead, producing an affordable, mass-market EV that could accelerate the adoption of sustainable transportation. This car would eventually become the Model 3, but there was a critical bottleneck in the way: the global supply of lithium-ion batteries. For Tesla, batteries were not just a component. They were the beating heart of its vehicles. High-performance EVs required batteries with unparalleled energy density, durability, and efficiency. However, the automotive industry had long relied on third-party suppliers for these components, and the global supply chain was nowhere near ready to support Tesla's ambitious production targets. By some estimates, even if Tesla cornered the entire world supply of lithium-ion batteries in 2014, it still wouldn't be enough to meet the company's goals for the Model 3. Elon Musk knew that if Tesla were to scale as planned, it couldn't remain at the mercy of external suppliers. The solution? Build its own supply chain from the ground up. Not just a factory, but the largest battery factory in the world. One so vast it could single-handedly double global battery production capacity. Musk called it the Gigafactory, a term borrowed from science fiction, reflecting the scale and ambition of the project. But this wouldn't be just any manufacturing plant. Musk envisioned it as a self-sustaining ecosystem, a factory that could mass-produce batteries at an unprecedented scale while driving down costs through vertical integration, advanced automation, and economies of scale. More importantly, it would be a beacon of sustainable energy, powered primarily by renewable resources like solar and wind, with minimal reliance on fossil fuels. The Gigafactory wasn't just a solution to Tesla's supply problem. It was a cornerstone in Musk's broader mission to transition the world to sustainable energy. However, building the Gigafactory was easier said than done. For starters, Tesla needed to find a location that could accommodate such an enormous structure, one that would eventually span over 13 million square feet, or roughly 100 football fields. The site would also need access to reliable renewable energy sources, abundant water for cooling and manufacturing processes, and infrastructure to transport raw materials efficiently. After a thorough search, Tesla selected a sprawling desert site near Sparks, Nevada. The state's incentives, including significant tax breaks, sealed the deal. But securing land was just the beginning. The next challenge was raw materials: lithium, nickel, cobalt. These were the key ingredients for Tesla's batteries, and their global supply chains were fraught with geopolitical risks, ethical concerns, and environmental challenges. Tesla had to think beyond the factory walls, investing in sustainable sourcing practices, recycling initiatives, and even its own lithium mining operations to ensure a steady and ethical supply of materials. Then came the design of the factory itself. Tesla's vision for the Gigafactory wasn't just about size. It was about efficiency. Inspired by principles of lean manufacturing, every aspect of the Gigafactory was engineered for maximum output with minimal waste. Musk often described the factory as a machine that builds the machine, emphasizing the idea that the manufacturing process itself was just as important as the product. Tesla's engineers worked tirelessly to optimize the flow of materials, implement advanced automation systems, and integrate renewable energy generation directly into the facility's design. The sheer scale of the project posed countless logistical and technical hurdles. Tesla had to build the factory in phases, starting with a fraction of the eventual footprint to begin production as quickly as possible. At the same time, the company was racing against the clock to develop its next-generation battery technology, designed to deliver higher performance at lower costs. This required close collaboration with Panasonic, Tesla's longtime battery partner, as well as significant investments in R&D. Despite these challenges, Musk's vision for the Gigafactory remained unwavering. It wasn't just about building cars or even batteries. It was about reshaping the way industries approached manufacturing, energy consumption, and sustainability. The Gigafactory would serve as a proof of concept, demonstrating that large-scale, sustainable manufacturing was not only possible, but essential for the future of the planet. By the end of 2014, the foundations of the Gigafactory were laid, both literally and figuratively. Tesla broke ground on the Nevada site, signaling the start of one of the most ambitious industrial projects of the 21st century. For Musk and his team, it was the beginning of a journey that would test the limits of engineering, innovation, and human determination. But for the world, it was the start of something even bigger, a paradigm shift in how we produce and consume energy, one that would ripple far beyond the automotive industry. This wasn't just a factory. It was a bold statement of what the future could be, and Tesla was betting everything on it. In 2014, Tesla broke ground on its first Gigafactory in Sparks, Nevada, a project so audacious that many industry experts dismissed it as a pipe dream. The vision was to create a manufacturing facility that would eventually span an astounding 13 million square feet of operational space, making it one of the largest buildings in the world by footprint. The sheer scale of the project was unprecedented, but for Elon Musk and Tesla, it was a necessary gamble. To meet the soaring demand for electric vehicles, EVs, and achieve the company's mission of accelerating the global transition to sustainable energy, Tesla needed a production facility capable of delivering batteries at a scale and cost that had never been attempted before. At its core, the Gigafactory was more than just a solution to Tesla's battery supply problem. It was a reinvention of the manufacturing process itself. Musk often referred to it as the machine that builds the machine, emphasizing that the factory was as much a product as the batteries and cars it produced. Every aspect of its design and operation was meticulously engineered to maximize efficiency, minimize waste, and push the boundaries of what a modern factory could achieve. Building the foundation. The construction of the Nevada Gigafactory was a monumental undertaking, fraught with challenges. Tesla adopted a phased approach to building the facility, allowing parts of the factory to begin operations even as other sections were still under construction. By 2016, despite the factory being only 30% complete, it was already producing battery cells. This phased approach was critical to Tesla's strategy, enabling the company to start generating revenue from the factory while continuing to expand its footprint. The early phases of construction were a race against time. Tesla was betting the future of the company on the success of the Model 3, its first mass-market EV. The Gigafactory needed to ramp up production at breakneck speed to supply the batteries necessary for Tesla to meet its ambitious production targets. Any delays could spell disaster for the company, which was already facing intense scrutiny from investors and competitors. Revolutionizing manufacturing. What sets the Gigafactory apart is its revolutionary design philosophy. Traditional factories are often sprawling, disconnected spaces where inefficiencies can creep in at every step of the production process. Tesla sought to eliminate these inefficiencies by designing the Gigafactory as a tightly integrated system. The layout of the factory was optimized to streamline the flow of materials, with every step of the manufacturing process occurring in close proximity to minimize transportation time and costs. Automation played a central role in achieving this level of efficiency. The Gigafactory is a hive of activity where robots and humans work together in a seamless dance of precision and speed. Advanced robotics handle repetitive and physically demanding tasks, such as assembling battery cells and modules, while human workers focus on tasks requiring dexterity, problem-solving, and oversight. This harmonious blend of human and machine capabilities allowed Tesla to achieve levels of productivity that were unheard of in the automotive and battery industries. Tesla also adopted cutting-edge production techniques to drive down costs and improve quality. For example, the company pioneered the use of dry electrode technology, which eliminates the need for costly and environmentally damaging solvents in the battery manufacturing process. This innovation not only reduces production costs, but also makes the process more sustainable. Sustainability at scale. Sustainability is at the heart of the Gigafactory's design. From the very beginning, Tesla envisioned the factory as a model for how large-scale manufacturing could be both profitable and environmentally responsible. The roof of the Gigafactory is covered in solar panels, which generate clean energy to power the facility. In addition, Tesla has integrated wind and geothermal energy sources to further reduce its reliance on fossil fuels. The factory's commitment to sustainability extends beyond its energy sources. Tesla has implemented extensive recycling programs to minimize waste, reusing materials like lithium, nickel, and cobalt from spent batteries to create new ones. This closed-loop system not only reduces the environmental impact of battery production, but also helps Tesla secure a stable supply of critical raw materials. Tesla's approach to sustainability isn't just good for the planet, it's also good for business. By reducing waste, improving energy efficiency, and integrating renewable energy sources, Tesla has been able to significantly lower the cost of battery production, making its EVs more accessible to a broader range of consumers. The pressure to deliver. By 2018, the stakes for the Gigafactory couldn't have been higher. Tesla was in the midst of what Elon Musk later described as production hell, struggling to ramp up Model 3 production to meet overwhelming demand. The success of the Gigafactory was critical to overcoming this challenge. Delays or inefficiencies at the factory could have catastrophic consequences for Tesla, which was burning through cash at an alarming rate. The pressure was immense, but Tesla's relentless focus on innovation and problem-solving paid off. By 2019, the Nevada Gigafactory had hit its stride, producing enough batteries to power hundreds of thousands of vehicles annually. The facility's success not only helped Tesla overcome its production challenges, but also positioned the company as a leader in the transition to sustainable energy. The rise of the Gigafactories. The Nevada Gigafactory was just the beginning. Building on the lessons learned in Sparks, Tesla began expanding its Gigafactory concept globally. Each new factory was designed to be faster, smarter, and greener than the last. Gigafactory New York. Located in Buffalo, this facility focuses on solar products, including Tesla's solar roof and Powerwall systems. It represents Tesla's commitment to integrating renewable energy into every aspect of modern living. Gigafactory Shanghai. Tesla's first Gigafactory outside the United States. This facility was built in record time and is a key hub for producing EVs for the Chinese market. Its rapid construction and efficiency have become a model for future factories. Gigafactory Berlin-Brandenburg. Tesla's first European Gigafactory. This facility combines state-of-the-art manufacturing with a strong focus on sustainability, including water conservation and renewable energy. Gigafactory Texas. Also known as Giga Austin, this facility is one of Tesla's largest and most advanced factories. It produces the Model Y and will be the primary site for manufacturing Tesla's highly anticipated Cybertruck. Each new Gigafactory represents a step forward in Tesla's mission to make sustainable energy and transportation a reality. These facilities are not just factories. They are symbols of what can be achieved when innovation, ambition, and sustainability come together. Legacy in the making. The story of the Nevada Gigafactory is one of bold vision, relentless determination, and groundbreaking innovation. What began as a risky bet has grown into a global network of factories that are reshaping the future of energy and transportation. Tesla's Gigafactories are more than just manufacturing facilities. They are beacons of hope for a sustainable future, proving that large-scale industrial operations can be both environmentally responsible and economically viable. Beyond the traditional factory, the Tesla Gigafactories are more than just enormous manufacturing facilities. They are a paradigm shift in how the world approaches production. For over a century, factories have operated as fragmented entities, with parts and raw materials sourced from an intricate web of suppliers scattered across the globe. This traditional supply chain model is highly vulnerable to disruptions and inefficiencies, which can drive up costs and compromise quality. Tesla's Gigafactories, however, aim to dismantle this paradigm by championing vertical integration. A a strategy where nearly every step of the manufacturing process, from raw materials to finished products, is brought under one roof. At the heart of this transformation is the production of lithium-ion batteries. These batteries are not merely components, but the lifeblood of Tesla's mission to revolutionize energy and transportation. Producing them is no simple task. It involves mining, refining, and assembling materials like lithium, nickel, and cobalt, industries with complex logistics, geopolitical implications, and significant environmental challenges. From ground to gigafactory, Tesla's approach to battery production starts long before raw materials reach the factory floor. Recognizing the risks associated with depending on third-party suppliers, Tesla has taken bold steps to secure its supply chain. This includes forging long-term partnerships with mining companies, investing in lithium and nickel extraction technologies, and even exploring the possibility of operating its own mines. By controlling the sourcing and refinement of critical materials, Tesla ensures a stable and ethical supply chain, reduces costs, and minimizes its exposure to price fluctuations in volatile global markets. Once the raw materials arrive at the Gigafactory, the process becomes a showcase of efficiency and precision. Tesla has implemented cutting-edge techniques like dry electrode technology, which eliminates the need for traditional solvent-based processes. This innovation not only reduces production costs, but also significantly lowers the environmental impact of battery manufacturing. Additionally, Tesla has pioneered recycling programs to recover valuable materials from used batteries, creating a closed-loop system that aligns with its commitment to sustainability. The role of AI and automation. While the physical scale of Tesla's gigafactories is impressive, their true revolution lies in the software. Unlike traditional factories, which rely heavily on static processes and manual oversight, Tesla's facilities operate as dynamic, adaptive systems powered by advanced artificial intelligence. Tesla's custom-built AI systems monitor and optimize every aspect of production in real time. They analyze vast amounts of data collected from sensors embedded throughout the factory, identifying bottlenecks, predicting maintenance needs, and suggesting adjustments to improve efficiency. For instance, these systems can anticipate when a piece of equipment is likely to fail and schedule preventive maintenance, avoiding costly downtime. Automation is another cornerstone of the Gigafactory model. Robots handle repetitive, dangerous, and labor-intensive tasks with unmatched precision, while human workers focus on areas requiring creativity, critical thinking, and fine motor skills. This seamless integration of human and machine capabilities allows Tesla to achieve levels of productivity and consistency that were previously unimaginable. The key to speed and innovation. Tesla's commitment to vertical integration extends far beyond battery production. In traditional automotive manufacturing, components like motors, inverters, and even seats are often outsourced to specialized suppliers. Tesla, however, produces many of these components in-house. This strategy has several key advantages. Cost efficiency. By eliminating middlemen and controlling production processes, Tesla reduces costs and passes these savings on to customers. Quality control. With direct oversight of every production stage, Tesla ensures that its components meet the highest standards. Innovation. Vertical integration gives Tesla the flexibility to experiment and iterate quickly. For example, the company's advancements in battery chemistry and motor design are often integrated directly into the production process without the delays associated with external suppliers. Energy efficiency and sustainability as core principles. Tesla's gigafactories are not just about building products. They're also about demonstrating that manufacturing can be sustainable. Each facility is designed to operate with minimal environmental impact, incorporating renewable energy sources like solar, wind, and geothermal power. For instance, the Nevada Gigafactory is equipped with a massive solar array on its roof, while the Berlin-Brandenburg Gigafactory integrates water conservation systems to minimize its impact on local ecosystems. Waste reduction is another focus area. Tesla has developed sophisticated systems for recycling scrap materials, such as aluminum, steel, and battery components. These materials are reintroduced into the production process, reducing waste and lowering the environmental footprint of the factories. Impact on the broader manufacturing ecosystem. The innovations pioneered by Tesla's Gigafactories are not confined to the company itself. Musk's vision of the machine that builds the machine has set new benchmarks for efficiency, sustainability, and scalability, inspiring other industries to rethink their approaches to manufacturing. Automotive competitors, electronics manufacturers, and even renewable energy companies are taking notes. The concept of vertically integrated, software-driven factories is gaining traction, sparking a wave of innovation across sectors. Companies are adopting automation, AI, and sustainable practices, often citing Tesla as the catalyst for these changes. Moreover, the ripple effects of Tesla's Gigafactories extend to local economies and communities. These factories create thousands of high-tech jobs, spur investments in infrastructure, and position their host regions as hubs for innovation. The Nevada Gigafactory, for example, has transformed the area around Sparks into a thriving tech ecosystem, attracting suppliers, startups, and researchers. A legacy of transformation. Tesla's Gigafactories are more than just a response to the growing demand for EVs. They're a bold statement about what manufacturing can achieve. By integrating advanced technology, sustainable practices, and vertical integration, these factories have redefined what's possible in production. The impact of Tesla's Gigafactories will be felt for decades to come. They are not just transforming the way we build cars and batteries. They are reshaping industries, inspiring innovation, and paving the way for a more sustainable future. Musk's vision of a factory as a living, learning system has set a new standard for what manufacturing can achieve, proving that big ideas, when executed with precision and determination, can change the world. In a world facing the dual crises of climate change and resource scarcity, Tesla's Gigafactories are not just factories. They are beacons of hope and ingenuity. They represent a radical shift in how humanity can produce, consume, and innovate while minimizing our impact on the planet. These monumental structures are more than just hubs of activity. They are proof that sustainability and ambition can coexist. Elon Musk's declaration that the factory is the product encapsulates a profound truth about the Gigafactories. Each one is a marvel of engineering, a symphony of human ingenuity and technological prowess. From the solar-covered rooftops to the AI-powered assembly lines, these factories embody the future of industry, a future where efficiency, sustainability, and scalability work in harmony. But their impact extends far beyond the cars and batteries they produce. The Gigafactories are reshaping global manufacturing norms, inspiring companies across industries to rethink how they operate. They challenge the status quo, proving that the impossible is often just the untried. As these factories scale and evolve, their ripple effects are already shaping the future of transportation, energy, and beyond. They are not just building machines. They are building a blueprint for a better world. Standing at the forefront of this transformation, Tesla's Gigafactories remind us of what's possible when bold vision meets relentless execution. They're not just changing how things are made. They are redefining what it means to make a difference. And as the world watches these colossal factories hum with life, one thing becomes undeniable. The future isn't being imagined. It's being built, brick by brick, battery by battery, and gigafactory by gigafactory. The revolution is here, and it's happening inside these walls.